today we are going to look into the fifth experiment of Anndl data science. So this is about designing, training and testing an MLP, that is a multi-layer perceptron, and the data that you would be using for this is a tabular data. That means you will be having a CSV file to deal with. The aim is you will be using various activation functions, you will be using different types of optimizers, and you will be trying to figure out what effect it is going to give you on the model. Okay, so to take this tabular data, you can take any tabular data. Here I have taken California house prediction data, quite a popular data set. So for this data set, the context here is to predict the price of a house, which can help the developer to determine the selling price of a house, and then it can also help the customer to arrange the right time to purchase a house, right? So there are three factors that is going to influence this price of a house. So you can actually use your concepts of machine learning for this, and you can see what are the highly correlated factors. Here, to ease you out, I am giving these three factors that are influencing there, which is physical condition, concept and location. You can even cross verify this. Now the problem statement is we have to design a multi-layer perceptron model which will be able to help us predict the house prices based on certain criteria in using California housing data set. So if I talk on data set, I have I provide you with the data set when we do the lab. So basically you would see that it is as per 1990 census data, wherein in California it is mentioned the location with respect to latitude, longitude, housing median range, number of bedrooms, population, total number of rooms, what is the average income, median income, median house value, what is the proximity from the ocean, and different types of households that are present. So all of these are the criteria that are included into your data set. Out of it you have to determine which of them affect the most, and then you are going to predict with respect to it. But the prediction is not using a predefined machine learning model, it will be using multi-layer perceptron model. So now what we are going to do here is we would be loading this particular data set, and you will be doing all the steps of pre-processing, which I'm not going to explain again now in this video because you are already well versed with it. So first what you would do is do the pre-processing part and find out highly correlated factors, and then you decide your training data set and testing data set. So once you have got that in your hand, you would be as usual creating a feed forward network using sequential container, and you will be connecting a fully connected layer using dense, and you will import these layers you will import these containers from the Keras TensorFlow module, and then you start adding up to your network. So here I have chosen a sequential network to which I am choosing different layers, like multi-layer perceptron it is. So this is my perception. Now you can design in the same way, or if you want, you check the result. If you are still not happy, you can include one more hidden layer and try to find out. The overall idea here is I have chosen your input dimension as 3 depending on the correlated factor. You just check once again for your correlation and try to figure out. And yeah, here you will be using various types of activation function. Here I am choosing ReLU. You will be doing for the others like sigmoid and all, tan head, sigmoid, you choose it and you try to find out. Now that because now I have got the output, I am choosing output as 1 obviously, and the activation function I am choosing here is ReLU. So if you can see, these are the number of parameters that are trainable that I get once I figure out the number of layers, and then I use, because it is regression, obviously I'll be using mean squared error as my loss function, and optimizer is Anndl. You have to change different optimizers and get me the results. Okay, so here I am giving my training data, and I'm choosing number of epochs as 50. Now you would be choosing, you can be using various optimizers like RMS propagation, stochastic gradient descent. Here I have chosen Atom. Please do for the remaining two also. Also I have chosen here ReLU. You choose other activation functions and try to at the end tabulate what results you are getting with respect to various optimizers and stuff. So for the thing that I have designed, I got for the 50th epoch, the output as the loss is this, and I have also tried to choose a prediction. I mean, took a sample and tried to predict it the mean absolute error over here. So you can use the same way and try to predict your mean absolute error. So I have taught you about Adam optimizer and ReLU. You will be doing for the remaining other optimizers like RMS prop and SGD. You will be also choosing various other activation functions like sigmoid and tanh, and then finally you tabulate and send me your results for assessment. I hope you get this. Thank you.